Hello, in this lecture I answer two questions. In the first question we find out the area of this green shape. In the second question we find out the length of this line segment PQ that is equals to x. We have to find out the value of x. So we start with the first question. In the drawing we have a semicircle. Inside this semicircle we have this small circle. In addition, we know that this is line segment AQ that is equals to 4 units in its length. This is line segment TB that is equals to 1 unit in its length. This is angle PQA that is right angle. This is angle STB that is also right angle. Again, our task is to find out the area of this green shape. So first of all, we define the radius of the big semicircle as x and the radius of this small circle as y. We define the center of this small circle, this point is point O, and we define the center of this semicircle, this point is point C. We define the point of tendency of tangent AB with this small circle. This point is point N. Likewise, we define the point of tendency of tangent PQ with this small circle. This point is point H. And we define the point of tendency of tangent ST with this small circle. This point is point L. And finally, we define the touching point of the big semicircle and this small circle. This point is point K. The diameter AB of this semicircle is twice as long as the radius. The radius is x. Therefore, the diameter AB equals to 2x. AB equals to 2x. In the next step, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equals to y. The radius ON is equals to y. The radius ON is known to point N, that is the point of tendency of tangent AB with this small circle. And whenever you have a radius that is known to the point of tendency, then tangent AB will be perpendicular to the radius NO. If AB is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. AB is the diameter, it is absolutely a straight line. So if you focus on the upper side of the straight line AB at this point, point C, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point C? We have this angle that is a right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. We join points O and H together by straight line. OH is of course the radius of this circle that is equals to y. The radius OH that is equals to y. The radius OH is known to point H, that is the point of tendency of tangent PQ with this circle. Whenever you have a radius that is known to the point of tendency, then tangent PQ will be perpendicular to the radius AO. If PQ is perpendicular to AO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum of rule 1. So inside the quadrilateral HO and Q, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 pieces angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, this 4 pieces angle must be equal to 90 degrees in its size. So inside the quadrilateral HO and Q, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to this quadrilateral NO and Q as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle HO and Q, side HO must be equal to the opposite side QN. HO is y, therefore the opposite side QN must be also equal to y units in its length. QN equals to y. According to what is given as the question, this is angle STB that equals to 90 degrees in its size. So if we focus on the upper side of the straight line AB, it's point T. Here the sum of the angles must be equal to 180 degrees according to rule 3. Again, rule 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of AB at point T? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we join points O and L together by straight line. OL is of course the radius of this circle that equals to y. The radius OL that equals to y, the radius OL is known to point L, that is the point of tendency of tangent ST with this small circle. Whenever you have a radius that is known to the point of tendency, then tangent ST will be perpendicular to the radius LO. If ST is perpendicular to LO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule 1. So inside quadrilateral OHTN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 pieces angle. In total, it must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this 4 pieces angle must be equal to 90 degrees in its size. So inside quadrilateral OLTN, we have 4 angles, and according to rule 5, any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to this quadrilateral OLTN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So a rectangle OLTN, side OL must be equal to the opposite side TN. But OL is y, therefore the opposite side TN must be also equal to y units in its length. QT is a straight line because it is part of the straight line AB. AB is a diameter, it is absolutely a straight line. QT is part of a straight line AB, and therefore it is also a straight line. So QT is a straight line, and therefore QT in total must be equal to y plus y, that is 2y. So QT equals to 2y units in its length. So I don't know if you found out that QT equals to 2y units in its length. So we know that the diameter AB equals to 2x. Again, the diameter AB equals to 2x. So AB equals to AQ plus QT plus TB. And again, if you found out that the diameter AB is equal to 2x, it is equal to AQ plus QT plus TB. So 2x equals to AQ is 4 plus QT equals to 2y plus TB equals to y units in its length according to what is given in the question. So in total, if you found out that 2x equals to 4 plus 2y plus 1, so 2x equals to 4 plus 1 is 5 plus 2y, so 2x equals to 5 plus 2y. Here we subtract 2y from this equation, and finally you get that 2x plus 2y equals to 5. So here we take out 2 as a common factor from those two expressions. So inside the brackets we left with x minus y equals to 5. So 2 times x minus y equals to 5. Here we divide this equation by 2, and finally you get that x minus y equals to 5 over 2. 5 over 2 is 2.5. So if you found out in total that x minus y equals to 5 over 2, that is 2.5. What is the length of this line segment CN? From the drawing it is very easy to see that CN equals to CB minus NT minus TB. Again, CN in total equals to CB minus NT minus TB. So already know, we have found out that CN equals to CB minus NT minus TB. And again, if you found out that Cn in total equals to Cb minus Nt minus Tb. So Cn in total equals to Cb. Cb is the radius of this semicircle, is equals to x. So Cb equals to x minus Nt. Nt equals to y. Minus Tb. Tb equals to 1. So in total, if you found out that Cn equals to x minus y minus 1. But we have only found out that x minus y equals to 2.5. So Cn in total equals to x minus y, that is 2.5 minus 1. 2.5 minus 1 is 1.5. So in total, if you found out that Cn equals to 1.5 units in its length. Cn equals to 1.5 units in its length. So write it down here. Cn This is 97 cm, that is equals to 1.5 units in its length. Here we can implement all 9 because of the fact that we have in the drawing an internal notch between the small circle and the big semicircle, that is to say they touch each other internally, this point K. We can implement here all 9. So repeat quickly on all 9. According to all 9, if 2 circles touch each other internally, then the straight line that connects the centers together passes for their touching point. So in the drawing, this is the big circle. Point O is the center of this big circle. This is the small circle. Point M is the center of the small circle. The straight line that connects the centers together is of course the straight line OM. And according to this all 9, the straight line OM must pass for their touching point, that is actually point P. Again, the straight line OM must pass for point P, that is their touching point. Well, according to all 9, OMP is one straight line. Again, OMP is one straight line according to this rule, all 9. So we can actually implement all 9 in our drawing. Right, because in our drawing, we have an internal notch between the small circle and the big semicircle, that is to say they touch each other internally in this point K. Point C is the center of this big semicircle, point O is the center of this small circle, so CO is the straight line that connects the centers together. And according to rule 9, the straight line CO must pass from point K, that is their touching point. Again, the straight line CO must pass from point K, that is their touching point. Or COK is one straight line. Again, according to rule 9, COK is one straight line. So, indeed, the straight line CO passes from point K, that is their touching point. So what is the length of the missing 9797 CO? CO equals to CK minus OK. Again, CO, this is the missing side CO, is equal to CK minus OK. So CO, the missing side CO equals to CK. CK is the radius of this semicircle, that is equals to X. Because it starts from point C, that is the center of the semicircle, and then at point K, that is the point of the semicircle itself. So CK is the radius of the semicircle, that is equals to X, minus OK. OK is of course the radius of this small circle, that equals to Y. OK equals to Y. So in total, we actually found out that CO equals to X minus Y. This is the missing side CO, that is equals to X minus Y. But we have already found out that X minus Y equals to 2.5. So CO equals to 2.5, because X minus Y equals to 2.5. CO equals to 2.5 units in its length. We already found out that Cn equals to 1.5 units in its length. So in the next step, I'll copy the right triangle ONC, this full right triangle ONC in the new page, and we'll implement with this right triangle ONC the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for polarized current. Essentially, this is the right small triangle CON that I go to the original domain, and this right triangle CON, all C squared, that is the square of the hypotenuse, equals to ON squared plus NC squared. So write it down. All C squared, that is the square of the hypotenuse, equals to ON squared plus CN squared. All C equals to 2.5 units in itself, therefore all C squared is 2.5 squared, that is 6.25, and it is equals to ON squared. ON is y, therefore ON squared is y squared, plus Cn squared. Cn equals to 1.5 units in itself, therefore Cn squared is 1.5 squared, that is 2.25. So in total, if you found out that 6.25 equals to y squared plus 2.25. Here we subtract 2.25 from this equation, and finally get that y squared equals to 6.25 minus 2.25 is 4. So y squared equals to 4. Here we take a water out of this equation, and finally get that y equals to the square root of 4, that is 2. So if we found out that the radius y of the circle is equal to 2 units in its length. We have already found out that x minus y equals to 2.5. We just found out that y equals to 2. So x minus y is x minus 2, that equals to 2.5. Here we add 2.5 to this equation, and we get that the radius x of the circle is equal to 2.5 plus 2 is 4.5. So the radius x of this semicircle is equal to 4.5 units in its length. 4.5 is 9 over 2. Our task is to find out the area of this green shape. So what is the area of the green shape? The area of the green shape must be equal to the area of the semicircle minus the area of this small circle. And again, if you found out that the area of this green shape, it is equal to the area of the semicircle minus the area of the circle. The area of the semicircle is equal to the area of the circle, that is pi x squared over 2. So the area of the semicircle is equal to pi x squared over 2. Minus the area of this circle. The area of this circle must be equal to pi times the radius of the circle squared. That is to say, it is pi times y squared. So that minus pi y squared, that is the area of the circle. X equals to 9 over 2. So in total, this expression equals to pi over 2 times x squared. X is 9 over 2, therefore x squared equals to 9 over 2 squared minus pi y squared. here we'll open the brackets of this expression and we get that we have pi over 2 times 9 over 2 squared. 9 over 2 squared equals to 9 squared, that is 81, over 2 squared, that is 4. So in total, the value of this expression equals to 81 pi over 2 times 4. 81 pi over 2 times 4. So it is 81 pi over 2 times 4. And 2 times 4 is 8. So in total, the value of this expression is equals to 81 pi over 8 minus pi y squared. So it is minus pi, and y is 2, therefore y squared is 2 squared, it is 4. So in total, the green shape equals to 81 pi over 8 minus 4 pi. Here we multiply 4 pi by 8 and then we divide it by 8 in order to overcome factor of this expression. And we get that 81 pi over 8 minus 4 pi times 8 is minus 32 pi over 8. 81 pi minus 32 1 pi is 49 pi over 8. Okay, again, if we found out that 49 pi over 8 is the area of the green shape. In terms of numbers, 49 pi over 8 is 19.24 square units. So if you found out that the area of this green shape, it is equals to either 49 pi over 8 square units in its size, or in terms of numbers, the area of this green shape equals to 19.24 square units in its size. So we finish with the first question. In the next step, I will present to you the second question, and we'll answer the second question of this lecture. Our task in the second question is to find out the length of this line segment PQ that is equals to x. We have to find out the value of x. So in the domain we have a semicircle. Point O is the center of this semicircle. This is line segment OS that is equals to 2 units in its length. This is line segment SB that is equals to 1 unit in its length. This is angle PTS that is a right angle. This is angle PQS, that is also a right angle. Again, our task is to find out the length of this line segment PQ that is equals to x. We have to find out the value of x. So first of all, we will complete this semicircle to a circle. And we will extend line segment TS by a straight line until it touches the circle. And we define the touching point of the extended line segment TS with this circle, this point is point M. It is given us the question that line segment PT equals to line segment TS in its length. So if we define the length of line segment PT as A, then the length of line segment TS must be also equal to A, because they are equal to each other according to what is given us the question. In the next step, we join points P and M together by a straight line. By joining points P and M, we created here with an angle PTM. This is peripheral angle PTM. That is equals to 90 degrees in its size according to what is given as the question, and peripheral angle PTM subtend on chord PM. Again, peripheral angle PTM, that is right angle, subtend on chord PM. So here we can implement rule 5. So I click quickly on rule 5. According to rule 5, any peripheral angle that is equal to 90 degrees must subtend on the diameter of the circle. So in the drawing we have a circle. This is peripheral angle MAN that is equal to 90 degrees in its size. And according to this rule 5, because of the fact that peripheral angle MAN is a right angle, therefore it must subtend on the diameter of the circle. Peripheral angle MAN subtend on MN, and indeed MN is the diameter of the circle. So according to rule 5, any peripheral angle that is equal to 90 degrees in its size must subtend on the diameter of the circle. We can implement rule 5 in our drawing. Why? Because in our drawing, this is peripheral angle PTM that is equal to 90 degrees in its size, and therefore according to rule 5, peripheral angle PTM must subtend on the diameter of the circle. Peripheral angle PTM subtend on chord PM, and therefore PM must be the diameter of the circle according to rule 5. So write it down. If you found out that chord PM is the diameter of this circle according to rule 5. In the next step, we will do a construction. That is to say, from this point S, we will do perpendicular on PM. Again, from point S, we will do perpendicular on PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point S and side PM. This point is point N. When doing this construction, actually created here, the small right triangles are in ONS. Those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha, because they are equal to each other. So in the right triangle PQO, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, this small right triangle ONS, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. To the same rule exactly, that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see from the drawing that the right triangle PQO is similar to this right triangle OSN according to angle similarity rule. I will explain anyway why those two right triangles are similar to each other. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So if you prove that all the figures of this right triangle PQO are correspondingly equal to all the figures of this right triangle NOS, and therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down. If you found out that the right triangle PQO is similar, this is the sign of similar, to the right small triangle ONS according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side NS of the small right triangle NOS over side PQ of the right triangle PQO is equal to side OS of the small right triangle OSN over side PO of the right triangle PQO. And again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side NS of the small right triangle ONS over side PQ of the big right triangle PQO is equal to side OS of the small right triangle ONS over side PO of the big right triangle PQO. NS is the missing side, so we leave it as it is, over PQ. PQ is the line segment that we are looking for in this question, and it is equal to X. We have to find out the value of X. And it is equal to OS, according to what is given in the question. OS equals to 2 units in its length, over PO. We have already found out that actually PO. So PO, it is definitely the radius of this circle, because it starts from point O and that's at point P. That is, point O is the center of the circle, point P is the point of the circle itself, therefore PO is the radius of this circle. OB is also the radius of this circle. What is the length of OB? OB in total equals to OS, that is 2, plus SB, that is 1. So in total OB equals to 2 plus 1, that is 3. That is to say, the radius of this circle, is equal to 3 units in its length. So PO is the radius of this circle, that is equal to 3 units in its length. So PO is 3. So in total, we actually found out that NS over X equals to 2/3. NS over X equals to 2/3. Here we will multiply this equation by X, and finally we get that the missing side NS is equal to 2/3 X. The missing side NS equals to 2/3 X. Okay. This is the missing side NS. It is equal to 2/3 X. In the next step, we'll define this angle as beta, and we will focus on the big right angle PTM. On the big right angle PTM, this angle equals to beta, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, if you focus on the small green triangle NSM, in this small green triangle NSM, this angle equals to beta. That is to say, angle beta is a common angle that belongs to both triangles. Angle beta belongs to the big right triangle PTM, and angle beta equals to also angle beta belongs also to the small green right triangle NSM. So this angle equals, if we focus on the green small triangle NSM, this angle equals to beta. This angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. It is very easy to see that the big right triangle PTM is similar to this one right green triangle NSM. I'll prove anyway why those two right triangles are similar to each other. First of all, this is angle beta, that is a common angle that belongs to both triangles. So we can write down that angle beta equals to itself as a common angle that belongs to both triangles. In addition, those two angles, they are both equal to 90 degrees minus beta, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, and therefore they are equal to each other. So if we found out that all the three angles of this big right triangle PTM are corresponding equal to all the three angles in this green right small triangle NSM. And therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down, and we found out that the big right triangle PTM is similar, this is the sign of similar, to the small right triangle NSM, according to angle similarity rule. And for the fact that the big right triangle PTM is similar to this small right triangle SNM, we derive that the following relationship exists between their sides. We derive that side SN of the small right triangle SNM over side PT of the big right triangle PTM is equal to side SM of the small right triangle SNM over side PM of the big right triangle PTM. We again from the fact that the big right triangle PTM is similar to this small green right triangle SNM, we derive that the following relationship exists between their sides. We derive that side SN of the small right triangle SNM over side PT of the big right triangle PTM is equal to side MS of the small right triangle NSM over side PM of the big right triangle PTM. NS, we have already found out that NS equals to 2/3 x. NS is 2/3 x over PT. According to our definition, PT equals to A units in its length. And it is equals to SM. SM is the missing side, so we leave it as it is. Over PM. We already found out that PM is the diameter of the circle. The radius of this circle is equal to 3 units in its length. Therefore, the diameter is 3 plus 3, that is 6. So PM equals to 6 units in its length. So in total, we actually found out that 2/3 x over A equals to SM over 6. Here, we will cross multiply this equation, and we get that 2/3 x times 6 equals to ASM. It again. Found out actually, after we cross multiply this equation, we actually found out that 2/3 x times 6 equals to ASM. 6/3 is 2, and 2 times 2 is 4. So in total, in this side of the equation 1, we have 4x. So according to equation 1, 4x equals to ASM. 4x equals to ASM. In the next step, I will present to you rule 15. We already talked about rule 15 in the previous lessons, so I'll repeat on rule 15 quickly, and we will implement rule 15 in our drawing. According to rule 15, if chord AB intersects with chord CD at point O, then AO times OB equals to CO times OD. So in the drawing we have a circle. Inside this circle we have chord AB that intersects with chord CD at point O. Point O is the intersection point of chord AB with chord CD. So in this drawing, according to this rule 15, the following equation is true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule 15 in our drawing. Why? Because in our drawing, we have chord TM that intersects with chord AB at point S. Again, we have chord TM that intersects with chord AB at point S. Point S is the intersection point of chord AM with chord AB. Therefore, all the requirements of rule 15 are satisfied, and therefore we can implement here rule 15. So I write it down. In our drawing, we have chord TM that intersects with chord AB at point S. Repeat again, all the requirements of rule 15 are satisfied, and therefore we can implement rule 15. According to rule 15, the following equation will be true. That TS times SM equals to AS times SB. Repeat again, according to rule 15, the following equation will be true. That TS times SM equals to AS times SB. According to our definition, TS equals to A times SM. SM is the missing side, so we leave it as it is. So in this side of the equation we have A times SM that is equals to AS times SB. What is the length of AS? AS in total equals to AO plus OS. AO is the radius of this circle that equals to 3, and OS equals to 2. So in total AS equals to 3 plus 2. AS in total equals to 3 plus 2, that is 5. AS equals to 5 times SB. SB equals to 1 unit in itself according to what is given as the question. So in total, if we found out that A times Sm equals to 5 times 1, that is 5. So according to equation 2, A times Sm equals to 5. This is according to equation 2. Well, according to equation 1, we have only found out that A times Sm equals to 4x. So we have actually two different expressions, two different equations for the expression ASM. Equation 1 and equation 2. Therefore, we get equation 3 that states that ASM according to equation 1 must be equal to ASM according to equation 2. And again, according to equation 3, ASM according to equation 1 must be equal to ASM according to equation 2. ASM according to equation 1 equals to 5. ASM according to equation 1 equals to 4x. And it must be equal to ASM according to equation 2. ASM according to equation 2 equals to 5. So in total, according to equation 3, we actually found out that 4x equals to 5. Here we will divide this equation 3 by 4, and finding that x equals to 5 quarters. 5 quarters is 1.25 units in its length. So if we found out that the length of the missing line segment PQ that equals to x is equals to either 5 quarters units, and those two numbers, it is equals to 1.25 units in its length. So finish with the second question. In the next step, I'll sum up the lecture. We'll start with the first question, of course. In the first question, our task is to find out the area of this grain shape. So in the domain we have a semicircle. We know that AQ equals to 4 units in its length. TB equals to 1 unit in its length. This is angle PQA, this is a right angle. This is angle STQ, that is also, this is angle STB, that is also a right angle. And our task is to find out the area of this grain shape. Okay. So first of all, we define the radius of this big semicircle as x, and we define the radius of this small circle as y. In addition, we define the center of this big semicircle, this point as point C, and we define the center of this small circle, this point as point O. AB is of course the diameter of this semicircle. The radius of this semicircle is x, therefore the diameter must be equal to 2x. So AB is the diameter of this semicircle, that is equal to 2x units in its length. In the next step, we define the point of tendency of tangent AB with this small circle, this point is point N. Likewise, we define the point of tendency of tangent ST with this small circle, this point is point L. We define the point of tendency of tangent PQ with this small circle, this point is point H. And finally, we define the touching point of the big semicircle with this small semicircle. We define the touching point of the big semicircle with this small circle, this point is point K. In the next step, we join points O and N together by straight line. Point O is the center of this small circle, point N is the point of the small circle itself, therefore ON is the radius of this small circle, is equal to Y according to our definition. The radius ON is known to point N, that is the point of tendency of tangent AB with this small circle. And whenever you have a radius that is known to the point of tendency, then tangent AB will be perpendicular to the radius NO. If AB is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. This gives us the equation that this is angle STB that is equals to 90 degrees in its size. AB as a diameter is absolutely straight line. So if you focus on the upper side of the straight line, AB is point T here, the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the areas on one side of a straight line is equal to 180 degrees. So which areas we have on the upper side of the straight line AB at point T, we have this angle that is the right angle, plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. In the next step, we join points O and L together by straight line. OL is of course the radius of this circle that is equals to Y. The radius OL that is equals to Y, the radius OL is known to point L, that is the point of tendency of tangent ST with this small circle. And whenever you have a radius that is known to the point of tendency, then tangent ST will be perpendicular to the radius LO. If ST is perpendicular to LO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the same rule, rule 1. So, in quadrangle OLTN, we have 1, 2, 3 degrees. The sum of 3 degrees is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrangle OLTN, we have 4 angles, and according to rule 5, any quadrangle that has 4 angles must be at a right angle, if not a square. So we learn to this quadrangle OLTN is a right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So right angle OLTN, side OL must be equal to the opposite side TN. But OL is y, therefore the opposite side TN must be also equal to y units in its length. We repeat it on the same process. On this side, actually, this gives us the equation that this is angle PQA that is equals to 90 degrees in size. So, if we focus on the upper side of the straight line, AB at point Q, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of AB at point Q, we have this angle that is the right angle, plus this missing angle, in total it must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. In the next step, we join points O and H together by straight line. OH is of course the radius of this angle that is equals to Y. The radius of OH is known to point H, that is the point of tendency of tangent PQ with this small circle. Whenever you have a radius that is known to the point of tendency, then tangent PQ will be perpendicular to the radius HO. If PQ is perpendicular to HO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So inside the quadrangle QN, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So So inside quadrilateral edge O and Q we have 4 daggers, and according to rule 5, any quadrilateral that does 4 daggers must be a rectangle in front of the square. So we relate to this quadrilateral edge O and Q is rectangle because it has 4 right angles. But we also know that the opposite sides of rectangle are equal to each other. So rectangle edge O and Q we have in rectangle edge O and Q, the opposite sides must be equal to each other. That is to say, edge O must be equal to the opposite side QN. Edge O is y, therefore the opposite side QN must be also equal to y units in its name. So in total, QT, that is the straight line, is equals to y plus y, that is 2y. QT equals to y. The reason that QT is a straight line, because it is part of the diameter AB, that is a straight line. Part of a straight line must be also a straight line. Okay. Another reason why QT is a straight line, because this is angle Q and T that is equal to 180 degrees in its size. And we know that any angle that is equal to 180 degrees in its size must be a straight line. Okay. So QT equals to y plus y, that is 2y. So AB is the diameter of the semicircle that equals to 2x. AB in total equals to AQ plus QT plus TB. Again, AB in total equals to AQ plus QT plus TB. Again, AB is equals to 2x equals to AQ plus QT plus TB. AQ equals to 4, QT equals to 2y, and TB equals to 1. So in total, 2x equals to 4 plus 1 plus 2y. 4 plus 1 is 5 plus 2y. So 2x equals to 5 plus 2y. Here we subtracted 2y from this equation. If I found out that 2x plus 2y equals to 5. Here we took 2 as a common factor from those two expressions. So inside the brackets we left with x minus y. So 2 times x minus y equals to 5. Here we divided the equation by 2. If I found out that x minus y equals to 5 over 2. 5 over 2 is 2.5. So x minus y equals to 2.5 units in its name. What is the length of this missing 97 cn? From the knowledge it is very easy to see that cn in total equals to CB minus NT minus TB. Again, cn in total equals to CB minus NT minus TB. Again, cn in total equals to CB minus NT minus TB. Cn equals to CB. CB is the radius of this semicircle, this equals to x. CB equals to x minus NT equals to y, and TB equals to 1. So total Cn equals to x minus y minus 1. X minus y is 2.5. So we substitute x minus y by 2.5. So in total CB equals to 2.5 minus 1, that is 1.5. So Cn equals to 1.5 units in its name. This is units inside Cn, this is equal to 1.5 units in its name. Because of the fact that we have here an internal knot between the small circle and the big semicircle, that is to say they touch each other internally at this point K, you can implement a rule 9. So let us click on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. So in the drawing we have two circles. This is the big circle. The center of this big circle is right point O. The center of this small circle is right point M. The straight line that connects the centers together is of course the straight line OM. And according to this rule 9, the straight line OM must pass through point P, that is their touching point. Again, the straight line OM must pass through their touching point, that is point P. Or OMP is one straight line. Again, according to this rule 9, OMP is one straight line. So we can implement rule 9 in our drawing. In our drawing, we have internal knots between the small circle and the big semicircle at this point K. So the center of this big semicircle is at point C. The center of this small circle is at point O. The straight line that connects the centers together is of course the straight line CO. The straight line CO must pass through point K, that is the touching point according to rule 9. Again, the straight line CO must pass through point K, that is the touching point, according to rule 9. So C or COK is one straight line. Again, COK is one straight line. If COK is one straight line, it means that CO must be equal to CK minus OK. Again, CO must be equal to CK minus OK. CO equals to CK minus OK. So CO equals to CK. CK is the radius of the semicircle, that is X. As OK is the radius of this small circle, that is Y. So in total, CO equals to X minus Y. CO equals to X minus Y. So in the next step, I copied the right triangle CON in a new page and implemented the Pythagoras theorem in this right triangle CON. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We already found out that X minus Y equals to 2.5 and Q1 equals to 1.5, ON equals to Y. So actually, this is the right triangle CON, the decorated from the original domain, according to the Pythagoras theorem, and this right triangle CON, all C squared, that is the square of the hypotenuse, must be equal to ON squared plus CN squared. All C squared equals to ON squared plus CN squared. All C is 2.5, therefore OC squared is 2.5 squared, that is 6.25, and it is equals to ON squared. ON is Y, therefore ON squared is Y squared, plus CN squared. CN is 1.5, therefore CN squared is 1.5 squared, that is 2.25. So in total, we found out that 6.25 equals to Y squared plus 2.25. Here we subtracted 2.25 from this equation, and found out that Y squared equals to 6.25 minus 2.25 is 4. So Y squared equals to 4. Here we took out of this equation and found out that Y equals to the square root of 4, that is 2. So the radius of this small circle Y equals to 2 units. We already found out that X minus Y equals to 2.5. X minus Y equals to 2.5. We just right now found out that Y equals to 2. So X minus Y is X minus 2, that equals to 2.5. Here we added 2.5, we added 2 to this equation, and finally found out that X equals to 2 plus 2.5, that is 4.5. 4.5 is 9 over 2. So we found out that the radius of the big semicircle, X equals to either 4.5 units, or in terms either to 9 over 2 units, or in terms of numbers, the radius X equals to 4.5 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? The area of the green shape equals to the area of the big semicircle minus the area of this small circle. Repeat again, the area of the green shape equals to the area of the big semicircle minus the area of the small circle. The area of the semicircle equals to pi x squared over 2. X is the radius, therefore the area of the semicircle must be equal to pi x squared over 2 minus the area, so the area of the semicircle is pi x squared over 2 minus the area of the circle, the radius is y, therefore the radius the area of this circle must be equal to pi y squared. The radius of the circle is pi y squared. So in total, the area of the green shape equals to pi x squared over 2 minus pi y squared. X is 9 over 2, therefore x squared is 9 over 2 squared. So in total, this expression equals to pi over 2 times 9 over 2 squared minus pi y squared. We open the brackets here, so we have here pi over 2. 9 over 2 squared equals to 9 squared, that is 81, over 2 squared, that is 4. Y is 2, so y squared is 2 squared, that is 4, so pi y squared is 4 pi. In the numerator we have 81 pi over 2 times 4, that is 8. So in total, the area of the semicircle equals to 81 pi over 8 minus 4 pi. Here we multiplied 4 pi by 8 and then we divided by 8 in order to become out of this expression. 4 minus 4 pi times 8 is minus 32 pi divided by 8. 81 pi minus 32 pi is 49 pi. So it is, in total, this expression equals to 49 pi over 8. So if we found out that the green shape equals to either 49 pi over 8 square units in its size, or in terms of numbers, this green shape is equal to 19.24 square units in its size. So we finish with the first question. In the next step, I actually presented to you the second question, and we solve the second question of this lecture. In the second question, our task is to find out the length of this line segment PQ that is equals to x. We have to find out the value of x. So in the drawing we have a semicircle. We know that TP equals to TS. This is line segment OS that is equals to 2 units in its length. This is line segment SB that is equals to 1 unit in its length. This is angle PQO that is a right angle. This is angle PTS that is also a right angle. Again, our task is to find out the length of this line segment PQ that is equals to x. We have to find out the value of x. So in the first step, we completed the semicircle to a circle, and we extended line segment TS by sideline until it touches the circle. We define the touching point of the extended line segment TS with this circle. This point is point M. In the next step, we join points P and M together by sideline. By doing all those constructions, we're going to do peripheral angle PTM. Peripheral angle PTM is equal to 90 degrees in size, and peripheral angle PTM subtend on chord PM. According to rule 5, any peripheral angle that is equal to 90 degrees in its size, exactly like this peripheral angle PTM, must subtend on the diameter of the circle. Peripheral angle PTM is a right angle, and therefore it must subtend on the diameter of the circle. Peripheral angle PTM subtend on PM, and therefore PM must be the diameter of the circle according to rule 5. So PM is the diameter. Point O is the center of the circle, point P is the point of the circle itself, therefore OP is the radius, OM is also the radius, OB is also the radius of the circle. OB in total equals to 2 plus 1, that is 3. So the radius OM is 3, the radius PO is also 3. In the next step, we did a construction, that is to say, from this point S, we do perpendicular on MP. Again, from point S, we do perpendicular on MP. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point S and PM. This point is point M. By doing this construction, we can do it as from right triangle S and O. Those two angles are defined as vertex angles, and they are equal to each other. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha, because they are equal to each other. So in the right small triangle O and S, this angle equals to alpha, this angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle POQ, this angle equals to alpha, this angle equals to 90 degrees, therefore this vertex angle must be equal to 90 degrees minus alpha, according to the sum rule that the sum of the angles in any triangle is equal to 1 by 80 degrees. In the next step, we proved that the big right triangle the upper right triangle POQ is similar to the right triangle, the lower right triangle ONS. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if you prove that all the figures of this triangle PQO are corresponding equal to all the figures of this right triangle ONS, and therefore those two right triangles are similar to each other according to angle similarity rule. So if it again, if we found out that the right triangle PQ is similar, this is the side of similar to the right triangle ONS according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side NS of the small right triangle ONS over side PQ of the big right triangle of the upper right triangle PQ is equal to side OS of the small right triangle ONS over side PO of the upper right triangle PQO. NS is the missing side, so we leave it as it is. Over PQ. PQ is X, that is the line segment that we are looking for in this question. And it is equal to OS equals to 2 units in itself, according to what is given in the question, over PO. We already found out that PO is the radius of this circle, that is equals to 3 units in its length. So in total, we actually found out that NS over X equals to 2/3. Here we multiply this equation by X and finally found out that NS equals to 2/3 X. This is the missing 9/7 NS, that is equals to 2/3 X. In the next step, we define this angle as beta. So in the right big triangle PTM, this angle equals to beta. This angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, in the small right triangle NSM, this angle equals to beta, that is to say, angle beta is the common angle that belongs to both triangles. This angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus beta, according to the sum rule that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that the big right triangle PTM is similar to this small right triangle NSM. I will explain anyway why those two right triangles are similar to each other. First of all, this is angle beta, that is a common angle that belongs to both triangles. So we can write down that the angle beta equals to itself is a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, both those two angles are both equal to 90 degrees minus beta, therefore they are equal to each other. So if you found out that all the figures of this big right triangle PTM correspond equal to all those figures of the small right triangle NSM. And therefore those two right triangles are similar to each other according to angle similarity rule. Repeat again, if you found out that the big right triangle PTM is similar, this is the sum of similar to the small right triangle MSN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side NS of the small right triangle NSM over side PD of the big right triangle PTM is equal to side SM of the small green right triangle NSM over side PM of the big right triangle PTM. Repeat again, we derive that side SN of the big right triangle NSM over side PT of the big right triangle PTM is equal to side SM of the small right triangle MSN over side PM of the big right triangle PTM. NS equals to 2/3 X over PT. PT is A according to our definition, and it is equal to MS. MS is the missing side, so we leave it as it is, over PM. We only found out that PM is the diameter of this circle, therefore it is equal to 6 units. So in total, we found out that 2/3 X over A equals to MS over 6. Here we cross multiply this equation and found out that two-thirds X times 6 equals to 8 times SM. 6 over 3 is 2, and 2 times 2x is 4x. So in total, this side of the equation, we have 4x equals to ASM. According to equation 1, 4x equals to ASM. Here, we can implement rule 15. So repeat quickly on rule 15. According to rule 15, if chord AB intersects with chord CD at point O, then the following equation is true. AO times OB equals to CO times OD. So in the drawing we have a circle, and we have code AB that intersects code CD at point O. So in this domain, the following equation is true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement all 15 in our domain. Why? Because in our domain, we have code TM that intersects with code AB at point S. Again, code TM intersects with code AB at point S. So all the requirements of rule 15 are satisfied, and therefore we can implement here rule 15. And again, in our domain, we have code TM that intersects with code AB at point S. So according to rule 15, TS times SM equals to AS times SB. Again, TS times SM equals to AS times SB according to rule 15. TS equals to A times MS. MS is the missing side, so leave it as it is. So in this side of equation, we have equation 2 we have A times SM, and it is equals to AS. What is the left of AS? AS in total equals to AO, that is 3. This is the radius of the circle, that is 3, plus OS, that is 2. So in total, AES equals to 3 plus 2, that is 5. Again, AS equals to 5 times SB. According to what is given in the question, SB equals to 1 unit in its length. SB equals to 1. So in total, if you found out that A times SM equals to 5 times 1, that is 5. So AMS equals to 5. This is according to equation 2, while according to equation 1, we already found out that A times SM equals to 4x. In the next step, we created equation 3 that says that A times SM according to equation 1 must be equal to A times SM according to equation 2. So again, according to equation 3 that we created, A times SM according to equation 1 must be equal to A times SM according to equation 2. A times SM according to equation 1 equals to 4x, and it must be equal to A times SM according to equation 2, that is equals to 5. So in total, according to equation 3, we have found out that 4x equals to 5. Here we divided this equation 3 by 4, and we found out that x equals to 5 quarters units. On terms of numbers, it equals to 1.25 units in its length. So we found out that the missing line segment PQ that equals to x is equals to either 5 quarters units in its length, or in terms of numbers, PQ that equals to x is equal to 1.25 units in its length. Okay, thank you very much.